All right. I'm back again, everybody. Last video, I lied to all of you, not because I wanted to, really because it was my own stupidity. I worked really hard on getting that particular video out there, only to wake up the day after and wonder what the hell did I just do? Now, I know a lot of people have this, like in music production and in programming and in game design, and you think you have this amazing thing going at 5 a.m., and then you go to sleep, you wake up, and it's just terrible. And you have no idea how in the moment you thought it was so smart. Anyway, last video I said I was generating sounds. Turns out I was not generating sounds. Not really, not the way I wanted to. I was generating sound where there wasn't one before, but it kind of sounded like crossfading, right? And that's because it sort of was in a conceptual kind of way. Now, it's not crossfading in a way where you put two clips on top of each other in a DAW and then it just mixes them together. But conceptually, the AI tool thing that I had was working that way. Uh, it was playing two sounds at the same time, but for the reason that it only learns to do that. It only learns to play back the sound. And the reason it can do that is because I'm mapping the sound to like a limited set of numbers, the latent space, but each sound is kind of unique, so it has a unique set of numbers, and so it just learns that, okay, this set of numbers is this sound, so this set of number is the other sound. And so when you're halfway in between, it realizes, oh, I could just play both at the same time and that's it. Now, if you want to generate unique sounds the way I do, you don't want that. What you want is one sound to be playing at one specific time and another sound playing at another specific time. And even better yet, you want one particular property of a sound to be at one specific time and one specific property being at another. Because otherwise, you get the crossfade, the superimpose effect that you saw, which is basically like taking two pictures, making one a little transparent, and putting them on top of each other, or making both of them transparent. And then you get like a something in between, right? Literally. I mean, it was doing its job. It's not like we should be mad at it. So you can understand that if a sound maps to what you can essentially consider a unique identifier, which in this case was the latent space, it can just remember the sound. But you don't want it to remember the sound. You want it to remember the property of the sound. So what you do is you take away the ability to have a unique identifier and you force it to use specific numbers in the middle, and then you tell it, okay, you take this sound and you somehow map it to this set of numbers in the middle, and then you take these numbers in the middle and you map that to a particular sound, and now it is forced. You force it to use a set combination of numbers and somehow convert every sound in your data set to those sets of numbers, and the other way around. And so now it has to learn to combine what they call vocabulary, I suppose, to create sound. And this has the intended, I suppose, consequence of extracting features from sound. And I don't know the right vocabulary for this because I'm not that smart. Most of the time I don't even know what I'm doing. But sound, it has multiple things: texture, timbre. It has I suppose phase, tempo, rhythm, whatever you want to call it. It has all these things that we sort of intuitively understand, right? When an object drops, it has the same volume most of the time, but it has a different sound. If glass falls on the floor, it's different than when metal falls on the floor, but it's still falling on the floor. And these things are all properties or conceptual things that we know, but we have to teach the neural network to do. So when you have this limited vocabulary, it's kind of figuring out, okay, I'm just going to use this for pitch at this particular time. I'm just going to use this for something else. But that brings us to the second issue. And when I've discussed the second issue, I will show you that I've at least gotten the codebook, the vocabulary working. The second issue is now, once you have this vocabulary, you want to understand the vocabulary as a person. Like I want to look at whatever numbers it has created, and I want to be able to understand, okay, all of these numbers are related to pitch. All of these numbers are related to texture. Now, I don't know how to do that yet. I've not looked into it because I really just wanted the vocabulary to be working first. And what the vocabulary has now allowed me to do is to play one aspect of one sound at a certain point in time and also another. And the way I've chosen to generate the sounds now is to have a sine wave. So the sine wave, to start, it's at 1, and then a little later it's at -1, and depending on that value, it will choose the property of A or the property of B. And I've done this because there's no other way to smoothly go between all of these properties. If I were to take a bunch of a vocabulary of sound A and then put it on sound B, it's going to sound like noise because I have no idea how to merge the two yet. All right, so here's the reconstruction, which works, by the way. This is reconstruction for metal steps 3. Oh, I hope, I so hope that I can figure out why I don't hear it. At least my microphone is working. That's good. Ah, here's the issue. Okay, I can hear it now. This is the reconstruction. I just love it. It's very nice. It's the right amount of quality. I don't want it to be any better than this. And here is the second sound. And you can see, if I put these below each other, that they're unique. And now I'm going to show you, I don't know if it's this one or if it's this one or if it's this one. Well, regardless of which one it is, you can tell that both of these, that all of these are slightly different. They're slightly different, but you know what they have in common? The fact that they're actually just the two of them merged at a different place. Now this is merging two sounds without crossfading. And to prove this, I'm going to just take this one as an example. This is the original one, this top one, and this bottom one is the second sound, the second one that I'm merging with. So I'm merging these two. Let me just put that one up here. I'm merging these two. And the third one, you can tell it's clearly stealing from number 3, and it's clearly stealing this area from both of them. It's kind of similar, and then it's kind of going like this, but not really. It is kind of shaped like this, but not really. And so you can tell that it's just kind of interpolating between the two, but it's interpolating the features of the particular sounds at that specific time, as opposed to playing both at the same time at different volumes. So here I'm going to play them next to each other so you guys can hear what I mean. I don't know how to select it. I think like this. There you go. And you might be wondering, like, why is this useful? Why are you doing all of this? And it's mainly because it creates hundreds of variations of footsteps that would take an unnecessary amount to record. And not just an unnecessary amount to record, it's just unnecessary to have because we know that footsteps are mostly similar with slight variations. And to human hearing, it doesn't really matter if it's like exactly the same or part combined with another one. And for use cases where you want variations of similar sounds, but you don't want to spend there all day working in your DAW, creating these variations, this is perfect. Now, in my next video, I really, really hope that I have received the ability to take properties of one sound, like the pitch or the texture, and put that on another one. But we'll see how far I can get with that.